Hi everybody. Today we'll be looking at an open source library released by the NFL called GLiTR. For background, you should understand what GraphQL is. GraphQL is a way of specifying queries for data and a way of answering those queries based on a schema. And what GLiTR lets you do is specify plain Java data types with getters and setters and use that to build up a schema that can be used to answer queries for the data. So right off the bat in this visualization, you can see that there's this central GLiTR package. That's going to be the entry point for this library. And one of the main branches of this package is the registry package. And the registry is basically responsible for mapping the plain Java data types into GraphQL data types so that queries can be answered. What I've done is set up a test application that uses GLiTR to specify GraphQL schema and then queries that schema for some data. We won't see the code for the test application, but we'll see exactly how GLiTR responds to those queries, the schema building, and so on. So let's go ahead and run this application. Cool. And you can immediately see that we're in the GLiTR package. That's the entry point. And the entry point is really the GLiTR builder. Now, a builder is a pattern in which you have an object where you specify some properties, and you don't have to specify all the properties, especially not the ones you don't care about. And then the builder is responsible for building an object with all the different fields that are necessary for that object, whether or not you specified them. So let's take a look at how that works. So we've created a builder over here. And what it's doing right now is initializing a bunch of different fields that it'll remember. And those are kind of the default values that it will be remembering. And now the application is calling this with query root method on the builder. And you'll see here that in response to that, the GLiTR builder is now setting the query root field inside of its instance. And that's how a builder works. You use a method to set some field, and the builder will remember that when building the object. So that's all we specified, but you remember that there were other fields. Those don't need to be specified because they have default values. So now the builder is taking those other values and creating an actual object. But first, it takes a detour into this type registry builder. Again, the builder pattern, and it has a couple of different fields. And here we're calling the with annotation to arguments provider map in order to set the corresponding field. Same with annotation to GraphQL output type map, which is setting the corresponding field, and so on. And we're building a type registry, pulling out all the fields it knows about and creating a type registry object. Okay, this GraphQL type factory will actually be responsible for creating the GraphQL data types that will be used to answer queries. And then we have some Java types that I'm not too familiar with, but we'll skip past that. All right. There's a lot of initialization code, as we can see. This is the type of thing that GLiTR basically takes care of us, so we don't have to worry about it. Normally there would be a lot of boilerplate for this otherwise. Okay, now we're back in the GLiTR builder, and it's finally created a GLiTR object. That's what it was meant to build, of course. And now it's going back to the type registry, and it's going to start building out the different GraphQL data types based on the Java classes that have been specified. All right. And this is where it gets interesting, because how does GLiTR know how the different classes that are present, how do they map to GraphQL data types? Well, the way it does that is using reflection. Reflection is a way of course, getting data about classes at runtime. And what we can see here is that there's this get method map. Already from the name, what we might assume is that this will get a list of methods that are present in a Java class. And we can verify that by just looking at the source code for that. And you can see that there's this class.get methods, and that's going to be the usage of reflection to get a list of methods. Okay. All right. So what else do we do? We saw that there was a lambda in there, and it's going through each of the methods, and it's checking if a method is eligible. If we were to look at the source code, we see this is just making sure that it is a getter or a setter. For example, there might be other methods that are not actually used to provide data back to a client that's querying for that data. And there's a bunch of different methods. Even for a simple class, those methods might come from superclasses, like from object. And so it has to go through all of those. All right. And for some of those methods, it's actually going to go ahead and do some work to create some data fetchers that will be used to answer queries later on. Okay. Right. Another thing we have here is this data fetcher, composite data fetcher. Again, I'm not too familiar with the internals of this, but this will be responsible for actually retrieving data when a query comes in. Okay. So at this point, you can see that there's a lot of setup. And here we're actually going to start doing some retrieving the schema and using that to make a query. And we've gone and asked to retrieve some data. And that's all there is to this application.